All right, continuing with these properties of equalities, let's look at classroom example 4. Right now I have 3/7 times x is going to equal 9. Now I want to get x by itself. That's what the instructions say, solve. To undo multiplying by 3/7, see this x is multiplied by 3/7. To undo multiplying by 3/7, I'm going to multiply this side by the reciprocal. That would make my 7's cancel and my 3's cancel. But if I multiply one side of the equation by 7/3, I need to multiply the other side of the equation by 7/3. You might see some people write it like that. So what's happening here is our 3's will cancel and our 7's will cancel, and I'm just left with, on the left-hand side here, x. I'm going to go ahead and simplify first here. This 9 is like 9/1. 3 goes into 3 once, 3 goes into 9 3 times. And now when you multiply your numerators, 3 times 7 is 21, and then 1 times 1 is 1. So your answer is 21. And you're going to check your work. What is 3/7 times 21? Does that equal 9? 7 goes into 7 once, 7 goes into 21 3 times, 3 times 3, 9 equals 9, and yes, it checks. So when you want to remove a fraction, you multiply by the reciprocal, swapping numerator and denominator. You can go ahead and practice that in practice 5. For classroom example 5, I'm multiplying x by 7. So you can think of it as multiply by 1/7. You can think of it as multiply by the reciprocal. But I think the way most people look at this is, right now I'm multiplying x by 7. To undo multiply by 7, I'm going to divide by 7. That's the inverse operation of multiplication, is division. So any number over itself is just 1. So on the left-hand side, I have x, and -42 divided by +7 is -6. And 7 times -6 is -42. So here you're multiplying both sides by the reciprocal. Here you're actually going to divide both sides to get x by itself. Go ahead and try practice 6. And for classroom example 6, let's simplify both sides by combining like terms first. So -7x and 2x is -5x. Bring down your equals. Here I have an x with nothing to combine with it, so I'm going to leave the x there. -3 and +20 is 17. And then -5. -3 and +20 is 17. And then 17 minus 5 is 12. So that's a +12, plus 12. Now if I want to get the x's by itself, I have one on the right-hand side and one on the left-hand side. So I want to get them both here on the left-hand side. This is a +1x. To undo the +1x is subtract x. But whatever you do to one side, you have to do to the other. -5x and -1x now gives me -6x. Bring down the equal, and you have the 12. And to get x by itself, I'm going to divide both sides by -6. Any number over itself is 1, so we get x is -2. And we're going to check our answer. -7 times -2 plus 2 times -2, does that equal -3 plus -2 plus 20 plus 5? -7 times -2 is +14. 2 times negative 2 is negative 4. Does that equal, okay, and I'm just going to do this on my calculator here, negative 3 minus 2 plus 20, and this is a minus 5, minus 5. That's going to be 10. And what is 14 minus 4? Does 10 equal 10? Yes, it does. So I've checked my work. This is really a typical type of problem that you'd see a lot on homework and on tests, where you've got to combine like terms, get x's on one side of the equal sign, and then maybe multiply or divide both sides to get the x by itself. So go ahead and try practice 8.